So everybody, welcome to the first in a series of 5 webinars between ADB, the Asian Development Bank, and Deltares, under the theme Collaborating on Innovative and Sustainable Solutions for Integrated Water Management. My name is Jeff Wilson. I'm a water resource specialist at ADB, and I will be moderating today's webinar. So first, a little bit on Deltares. I've known Deltares since I was an engineering undergrad more than 30 years ago. At that time, they were known as Delft Hydraulics, and they were the preeminent hydraulic laboratory and world expert in physical and numerical modeling of hydrology and engineering hydraulics. Now, as Deltares, they are a specialist consultancy working on smart innovation in the field of water, and a knowledge partner of the Dutch government. As an independent Dutch-based knowledge institute, Deltares have nearly 900 staff covering almost every aspect of water and hydraulic engineering. So ADB and Deltares intend to build a collaborative partnership in which Deltares uses its knowledge and expertise and tools to facilitate innovation and sustainable solutions for issues pertaining to the use of water and risks of soil and water. So together, ADB and Deltares have developed a stimulating series of webinars, which I think you'll find of interest. Today's webinar is on Deltares' Resilient City Toolbox for urban resilient planning. After today, we'll be having a series of webinars at the same time every Tuesday fortnight until early October. And we'll be covering such topics as disease transmission and health risks through water systems, dynamic adaptive policy pathways and climate adaptation, a hydrological basin approach for the Yellow River in China, and finally, the future of hydrological forecasting. So today we're honored to have Frans of Deltares to present on a Resilient City Toolbox for urban resilient planning. One of the main pillars of ADB's Strategy 2030 is livable cities. And in this context, Frans will discuss a number of questions. What are the main drivers and mechanisms that motivate us to take action? What makes action urgent? What are the leading principles that will help us find appropriate solutions for a more resilient urban environment? How can we explore and evaluate potential alternatives? And the number of measures we can take is huge. How do we make a choice? The Resilient City Toolbox is developed to assist in this search. So by way of introduction, Frans van der Veen is a team member of the Urban Land and Water Management at Deltares and Associate Professor of Urban Water Management at the Faculty of Civil Engineering and Geosciences at the Delft University of Technology. Frans will present for about 30 minutes, after which we will have about 30 minutes of Q&A, which I will moderate. Over to you, Frans. Thank you.
Thank you, Mr. Wilson, for this introduction, and above all, thank you for having the opportunity to contribute to this series of webinars. I hope the audience is going to enjoy what they hear, and well, many questions will be brought up. In the meantime, I'll try to switch. Okay. Mr. Wilson just introduced Deltares briefly, so that this was a slide introducing that. What I wanted to tell you is about, indeed, what makes action urgent, a bit about the planning strategy for resilience and the planning support toolbox and the tools we use. Let's move on and first focus on, well, what is urban resilience from a water perspective? And because, well, resilience is in general is a wide word, of course, but from a water perspective, it was the capability of a society to prevent or cope with the impacts of climate change, sea level rise, including its technical, institutional, economic, and cultural ability. So, well, first of all, it focuses on climate change impacts, what is expected from to happen to us. And it focuses on flood risk management, drought, water quality, the integrated design, inclusiveness. All these components are to be included in the total plan that we have to make for urban resilience. But what makes urban resilience so important? Why? What is the reason to strengthen that urban resilience? And that, of course, starts with the whole issue of urbanization that is going on worldwide. Our cities are rapidly growing. But we also have an aging population to take care of. That is, the demands will change over time. We have a robotization going on in society. We are talking about smart society, about Internet of Things. That will definitely change the way we deal with our community. Like this webinar is no longer a meeting in person, but it's broadcasted via Internet. We have a densification of the city going on. The city is becoming more and more dense. To avoid urban sprawl, we start densifying our cities, but that makes the risks increase over time. Mobility is changing, as everyone knows. We have an energy transition to take care of. We have gender issues and income issues to take care of in urban resilience. And last but not least, there is a lack of money all around the world. So the struggle for money is going on everywhere. And so we have to be very, very careful with the budget. And of course, there is that issue of climate, not only climate change, but existing climate. We already suffer from flooding, from river flooding, coastal flooding, heavy rainfall. We suffer from droughts, not only bringing dry gardens, but also threatening the stability of our levees, introducing land subsidence and so on. And we have that heat issue. And that heat issue, as is illustrated in a couple of pictures here, can only be dealt with if we have sufficient water to cool our cities. That water is an important coolant medium for our cities. But it's not only about threats and challenges that we have to talk about resilience. It's also about the opportunities to use water as a resource to improve urban resilience. To give it just a couple of examples, first of all, let's think about water harvesting, about the introduction of more sources than one single source of water supply from the public tap. Rainwater harvesting is becoming an issue worldwide, I think, to diversify our sources. Then we can make our water surfaces. Well, we can make better use of these water surfaces. We can build on them. We can float on them, above them. Water surfaces are not areas that you cannot use. They can be used in very different ways in the urban environment. Water and green are of course important for biodiversity, but can also be used for food production in our urban environment. Urban agriculture is picking up rapidly, and I think that is a way that will develop in the next decades pretty fast. Water and green is used for recreation and well-being for the people of the city. That is quite clear. Water is appreciated in the urban environment as an amenity if it is clean and accessible. So we can develop that capacity as well. And as I said, water is also a coolant for the city. So hey, it cools the heating. But at this very same time, these water surfaces can be used as an energy collector. The water surfaces collect enormous amounts of solar heat that we can use in our urban environment for heating if necessary. All these options are possibilities to improve our resilience in our urban environment. And that brings me to the issue of resilience planning. And the resilience planning is by any means a sort of a tiered approach. We have to take 3 steps. The first step is to scan the vulnerabilities of the urban environment. We call that stress testing the urban environment for climate and climate change. The second step is the selection of strategies to reduce that vulnerability and to set targets. That is an important step to prepare for the last step. And the last step is this, to select the adaptation measures in our environment. And I will briefly walk through this, these 3 steps, of course, focusing on step number 3. In step number 1, it is, of course, where we have to include issues like flood hazard management, to see where the hazards are, where the city is exposed to these hazards, where the risks are, the sensitive objects, where the vulnerabilities are. This is the type of analysis that is to be made in step number 1, to make a complete overview of all the vulnerabilities. This is to be done for flooding, but also for drought and for heat stress, and maybe for land subsidence, so also for the other issues that are at stake in the physical environment of our urban areas. Moreover, we, however, have to take a look at the soft side of the urban environment, the governance and the institutional arrangements, to see where the weaknesses are in these institutional issues. This could be done, for example, by analyzing the so-called primo chain, making an analysis of the existing policies, the existing regulatory frameworks, the capacity to implement solutions, to maintain solutions, and the organization and financing. Well, this is called the chain approach because, well, the chain is as strong as its weakest link, as we know. So if one of these links is weak, we will have a problem introducing these solutions. And then it comes to strategy, and well, one of the first steps in strategy that we are all very much aware of is the fact that nowadays we have to retain and store the water instead of draining the water. The Chinese term of sponge city approach is very well known. We need a sponge to capacity to avoid areas being flooded. Water is to be retained and detained where it comes from the sky and stored locally, so that we don't need to drain it right away, and so that we can avoid large flood peaks in our river systems. But okay, that is an important strategic component. Retain and store before draining it. And that brings us to, in the Netherlands, to what we call the multi-level protection strategy. We need, at level 1, we need strong levees, strong dikes to protect us from the rivers and from the coasts in our delta areas. But that is not enough. The fact that we create this levee system also introduces an inland area that is like a bathtub. And if it's raining heavily, that bathtub will fill up. So we need measures to avoid flooding in that in these lowland areas, and that's why we need flood-robust spatial planning. In addition to that, at level 3 we need flood warning and emergency plans, of course, to prepare for anything that could happen to us. A strategy for flood protection. This is. Then we need a so-called 3-point approach for resilience. And this is, I think, a very important step as compared to the past. In the past, we made an analysis of what was needed with a certain return period. And as a hydrologist, as a hydraulic engineer, we made a design for a levee or a pumping station or whatever was needed to protect us up to that certain level. Up to once in 10 years, once in 100 years flood, whatever. But 2 more points are very important. This is a point that happens 365 times per year. That is in the everyday situation. If your solution that you have designed for this extreme situation is not contributing to everyday value, well, that is a missed opportunity. So we should develop solutions that also contribute to the value of the urban environment every day. The third point is another issue, and that is, well, it's clear that every now and then, whatever design we make, this criteria will be exceeded. So if you design for a once in 100-year flood, if the once in 200-year flood comes in, your system is allowed to fail. Well, when it fails, we should, of course, minimize the damage of that failing system. That is the other challenge that we have to take care of, and that is one of the strategies to make our design so that we minimize the damage of that failing system. And this is the so-called three-point approach for urban resilience. And last but not least, the last component I would like to bring up is say the movement we see from traditional gray, underground, invisible solutions to nature-based solutions in the urban environment. And well, let's be honest, if you see these pictures, it needs no explanation why these solutions are attractive to the urban environment. They create extra value to this urban environment and on the everyday situation. They are more flexible and turn out to be cost effective, despite the fact that they need more space. They take urban space. So this is a movement that we have to consider when we move to our next step. And the next step was that adaptation planning. Well, in that adaptation planning, we first of all have a problem to deal with. And that problem to deal with is the fact that we have simply too many solutions. It's not the problem that we have no solutions in climate resilience. It is the problem that we have many solutions, many blue, green, and gray solutions are available. Whether you call them ecosystem-based adaptation, nature-based solutions, sustainable urban drainage systems, whatever you call them. The problem is we have to make a choice. And if you want to make a choice with the very, we have to take consideration of very many disciplines and aspects when implementing these solutions. So it's quite hard to make an evaluated choice, and that's in that context we need collaborative planning. We need the co-design of solutions. As you can imagine, these blue-green solutions require many different fields of expertise, urban planners, drainage experts, landscape designers, project developers. Everyone has a say and has to have a say in the design of these solutions. The more because all these stakeholders have to support the plan that is to be developed and implemented in the end. Such solutions, as a result, will be very location specific. It depends on local knowledge and local preferences what will be implemented in practice. The solution for city A can be completely different than the solution for city B. Moreover, the discussions that we have during that collaborative planning process tends to focus on the opportunities and the benefits and the co-benefits of these specific interventions rather than on the cost. So there is a balanced discussion about, say not only the cost of these interventions, but also the opportunities, benefits, and co-benefits. And indeed, we can say that during these discussions, the benefits are maximized while the risks are minimized. And maximizing the benefits is a very important step to take in this discussion. So if it comes to planning support tools, well, we should have support tools that facilitate and structure the discussions among all these experts and the stakeholders, the local representatives, and how to organize that process. Moreover, it should fit the structure of our planning and design process, which is often even a legal structure. But in general, this is characterized by an initiative phase and a design phase. In the initiative phase, ending with the program of demands, and the design phase starting with the conceptual design and then finally moving towards the final design ready for implementation. And this is precisely where the Resilient City Toolbox comes in. Because at the end of the formulation of the program of demands and at the beginning of the conceptual design, that is the moment that people can sit together and discuss options and opportunities. And that is precisely what the Resilient City Toolbox is meant for. The output of the Resilient City Toolbox, as you can see, is input for the further design phase, for the detailed design. So asking yourself the question, what is the Resilient City Toolbox meant for? Well, it is, first of all, meant to support the dialogue with all the stakeholders, the experts, the local representatives, the finances, the constructors, about the options and alternatives. Which measures can be implemented where and how? That is the key question we would like to answer in using the toolbox. Having a dialogue, standing around the table like shown on the picture here. This was a workshop in Berlin with different experts around the table. We discussed what could be done where in that project area. But we also see that during that discussion, stakeholders, participants become aware of the many solutions that they can choose from, because many people, well, hardly have an overview of the many solutions they can choose from. So they have to learn a lot about the potential solutions. The toolbox provides first estimates of the hydrological effectiveness and the costs of the measures. These are first estimates, enough for this preliminary phase of design, not insufficient for the later phase of design, but it gives you an opportunity to discuss the pros and cons of different alternatives. And the results are shown on a map. The people are contributing to that map and to see what can be done where in that area. Well, the structure of the toolbox is such that it's built up first with a measure selection assistant. So it evaluates the applicability of the different solutions in a specific area, given the conditions in that project area. And the next step is an effectiveness assessment tool, as we will see, to evaluate what we are projecting in that specific project area. Indicators of the effectiveness of the measures are for pluvial flooding. First of all, of course, that retention capacity, that sponge capacity that is needed, quite crucial in our thinking. But also a return time factor for peak flow reduction is important. For drought reduction, we included the groundwater recharge as a metric. For heat stress reduction, it is evaporation, annual evaporation and estimates, and the number of cool spots, and moreover some estimates on water quality improvements, and last but not least also estimates, very preliminary estimates of the costs of construction and the costs of maintenance are included. So these are the metrics, and well, the metrics for the hydrological metrics are calculated by using a simplified model, so not a complex hydraulic model, but an urban water balance model, that a multi-reservoir model that takes into consideration the hydrological conditions in my project area. How much area is paved, how much is unpaved, what type of area is there. We run long time simulations, and then we can estimate what the effectiveness of the different measures is. But we also need this model to estimate how much sponge capacity is needed in that project area. By having access to the land use data and to a long series of rainfall data, evaporation, climate change assumption, and that urban water balance model, we can calculate the relationship between the discharge capacity that could be available in a specific area and the storage capacity that is required. Well, of course, the more you can discharge, the less you have to store. But that discharge capacity tends to be limited because you will simply flood downstream residents or downstream cities if you discharge too much. And one of the principles in hydrology is never shift problems. Well, if you don't want to shift problems, say you have to limit your discharge capacity to your downstream neighbors. So that brings us to the need for storage capacity as shown in this graph. Well, that brings me to the point where I could switch to the demo of the toolbox. That toolbox is available for everyone. It is the URL is shown here, and everyone can go there. You can play around with it, but be aware that the toolbox needs to be customized for a real local application. Not only the cost figures are to be adapted for an application in any country, but also, for example, the climate figures. You can imagine that a bioswale in an area with a very dry climate performs different from a bioswale in a very wet climate. So you have to customize the effectiveness calculations if you want to apply a toolbox in a real case. But on the other hand, you can explore alternatives by yourself, by simply using the tool, or you can co-create plans, and you can export these plans on a map with its corresponding effectiveness results. Now let me do something very dangerous, and that is switch to the other presentation. Let's see what is happening. I have problems with the bar here.
Yep,
I hope you can see this, the Xiangtan training area now. Can you?
Yes, I can confirm that.
Okay. Well, thank you. Well, what is visible now is well, we're now in the middle of a session. This was a training session where we had 2 or 3 weeks ago with the tool for Xiangtan. This Xiangtan tool is not yet customized. That's going to happen in the project, but okay, this is an area in Xiangtan, a project area, as you can see, and we started designing first measures in that area. Well, I will first show how to use the tool and to implement measures in this specific area, and then how to start up the project. But let me first push this button. This is the layers button. Here you can see that we have this aerial photograph that is visible now. We have a satellite image we can choose, we can switch on, but we can also add layers. And normally we add layers like the flood hazard map, or the drought stress map, or the land subsidence map, the digital elevation map. Is all included in this list, but we can add layers if available. Another issue is the fact that this aerial picture needs a high resolution, because we would like to zoom in quite close so that we can really look in someone's backyard to see what can be done there. That's this button. If we go to the measures, what we see to the left is, say, the applied measures in that specific area. We can see a bioswale here, and there was a green roof and a wet pond, and apparently, this is my project area where I can zoom in and out, and this is the results screen to the right, with the indicators, the metrics shown in this study. Suppose I would like to add a measure. I push the measure button, and now I have an overview of the measures that I can choose from. Well, as you can see, there's a long list of measures you can choose from, and well, if you don't know what a water square is, for example, you can push the Learn More button. And if you push the Learn More button, it shows you a little bit of background information on what the water square could look like, to give an impression in words and in images. This is available for all the measures included in the toolbox. So, but suppose that there was a nice roof that I just had in mind, and I want to go for a green roof with drainage delay in that specific area. So I say choose. What I have to do now is I have to indicate the area where I could push the green roof, and this is an aerial element I'm going to add now. So I can just click the corners of this roof now. Double click is finishing it, and what it says now is, well, you selected the green roof for this building. What the default water storage is 10 centimeter. Well, but okay, I could increase that if you like. And of course, the inflow area is 1. So if I push the Done button, this solution, green roofs with drainage delay, is now included in my solution package. Similarly, I have linear elements that I can include. Let's go for a bioswale somewhere. I can imagine that you draw a bioswale here. Then I could introduce a linear element, say, okay, I want to introduce a bioswale from here to there. Well, now I'm doing this on a screen, but normally this is done on a touch table, put on a table that people can stand around, that we can have a discussion on what solution to put where. Well, the water storage depth default is 35 centimeters, the inflow area 1, and the width of 1 meter. Now let's make it a wider bioswale, and push the Done button. In the meantime, you see that the figures in the results screen are changing. And if I want to know what my bioswale is doing, I can click on this. And now I can see that my bioswale created almost 79 cubic meters of storage. It has effects on the return time factor, the groundwater recharge, the evaporation, etc. There's a cost estimate here. As I said, it's all estimated now on Dutch cost prices, so it's highly irrelevant for Xiangtan, but this is the way the tool works. And well, all the measures have an effect on water quality parameters. I could also show this as a table with an overview of all the results of the measures, etc. Now let's move to the very beginning of the tool. I have to hurry. And this is a way to switch from project to project. We can also start a new project. If you want to go to Manila, I could simply ask for Manila, and we can start opening a project in Manila. But this is a way the area can be used. That project again to demonstrate something else. Back in Xiangtan, I can also go to my project settings. This is the first step you take when entering a project. You have to give in the project area, and then you have to fill in a number of properties from the project area. When that is done, you can go to setting the project targets. And the project targets, like storage capacity or return time factor, you can fill in any value you want here as the target that you would like to achieve, so that the target can be compared to the realized value here in your right panel. And we can also illustrate that in a more graphical way by putting it in bars. Personally, I prefer the numbers, but I'm an engineer, so but this is the way to introduce targets, and we can toggle these targets on and off if you like. Whatever is relevant, we can include them. So this is a brief demonstration of the tool. And let me conclude by briefly showing a couple of applications. I'm running out of time, as I see. Well, as I said, there was a large application in the city of Utrecht, in a fair area where we used the tool with many stakeholders to explore potential adaptation options. We used that same tool and the water balance model to analyze the water balance and to see where changes in the flows would be needed. It was a very densely urbanized area with hardly any infiltration. So the question was, could we reintroduce groundwater recharge there? Well, we started developing solutions with the toolbox, as you have seen, and we drafted a number of alternative solutions with the team, so that the team started comparing different options, different alternative solutions, to find out what was the best way to go. They had a very good discussions once they had developed a couple of alternative plans for that specific area. And currently they are really building that lower right corner building as one of the buildings part of the area. Another application that is relevant is in New Orleans. We delivered a customized version of the toolbox to the city of New Orleans for their stakeholder engagement meetings. We had very intensive discussions with the stakeholders, and we trained the facilitators in New Orleans so that they can have own sessions with facilitators on what could be done where in the area, so to have a wide support for all the solutions that are taken. And last but not least, an application for the Asian Development Bank for the Xiangtan city in Hunan province in China. We developed a Chinese version and I customized that version for Xiangtan in China and applied that for both retrofitting blue-green measures in the existing urban environment, as well as for, well, this is shown here, a new built hospital area that is projected now, where a lot of retention had to be created. Rainfall intensity can be quite high there. As I said, rainfall intensity can be quite high. That's why we had to recalculate these storage discharge frequency curves, and so that indeed you can see that it needs quite a bit of storage capacity if you want to reduce the discharge capacity to the river there and avoid flooding further downstream. Moreover, one of the problems there that we encountered was the wide variety of partners and parties and bureaus and departments that had to be involved in the decision making and in the planning. We made a stakeholder analysis, and as you can see, all these bureaus have a say in implementing these solutions. But once you stand around the table, you can have a good discussion with all the participants on what would be feasible and what is unfeasible in a specific area. And that is precisely what the toolbox is meant for. Well, to conclude, some more information on background information. Upper line, the public wiki contains very extensive descriptions on how the calculations are made and all the background information. And further, some publications issued over the past couple of years. Sadie McEvoy did her PhD thesis, had published 3 or 4 articles on the toolbox now, on all the practicalities and the applicability and the pros and cons and the best ways to do it. So if you want to know all the background information, a lot can be found in there. Well, thank you very much for listening, and I'm looking forward to answer your questions.
Many thanks, Frans, for such an interesting presentation. Now we'll continue the Q&A until the hour. That gives us 12 minutes. If you can post your question into the chat, that would be helpful. In the meantime, Frans, I do have one question. There are many possible futures considering, for example, climate change and urbanization. How does the Climate Resilient City Toolbox address these many possible futures? Thank you.
In 2 ways. First of all, I already showed the storage discharge frequency curves. You can imagine that you run different future climate scenarios to calculate these curves under different scenarios. That's what we did basically in Xiangtan, to see how sensitive the storage demand is given the uncertainty in the climate change. That is one. Of course, it's also uncertainty in the urbanization pattern. You can take that into consideration in your urban water balance model as well to set the criteria. And last but not least, this uncertainty is of course a subject of the dialogue that takes place over the table. So that is another reason to develop different alternative plans. to see what is the most flexible solution to the future.
Thank you. Frans, can you open up your chat dialog box? There are a number of questions there. Perhaps you could just go through them directly.
First, I have to see how.
In the meantime, and the first question comes from Doreen. She's requesting a copy of the presentation after the webinar. Right. Doreen, I'd ask you and anyone else who's interested, please contact me on gwilson@adb.org. I repeat, gwilson@adb.org. Can you see the questions, Frans? Okay, Regava Neti has asked, does the toolbox simulate different scenarios? And I think the answer is yes, you've explained that. Okay, Vicky Ferrer says, who's the target users of the toolbox? Is it very technical?
No, it's not very technical. The idea is to use it in that conceptual phase of design. And during that design, of course, there will be water managers around the table, but also urban planners, landscape architects, traffic engineers, whoever is useful for the dialogue and depending on the local situation, of course. That is the way to open the dialogue by keep the level of technology low in the discussion, making the dialogue understandable for everyone.
Thank you. Chris Springers says, how does the toolbox cope with land subsidence?
Land subsidence is not covered by the toolbox, but is covered during the stress testing. As I said, the land subsidence map could be one of the maps that is introduced in the toolbox as one of the map layers. But the calculations for the land subsidence are to be made in advance during the stress test phase.
Great, thank you. Christina Gregorio asks, what are the prerequisite governance framework enabling environment needed, mentioned in the beginning, to facilitate the use of the toolkit between the initiate design stages of solutions?
First of all, the willingness to sit together with the different experts and bureaus, the willingness to put energy into that, see what the area is. The second requirement is data. We are in a position that well, the demand for data is not very intensive, but if there is no data on rainfall, if there is no data on land use, if the aerial images are poor in quality, you cannot zoom into someone's backyard. That is the sort of problems that we encounter as boundary conditions for the applicability of this tool. But in general, we can develop a workaround. Even though you have these difficulties, you can still use the toolbox for training purposes, for example, to make people aware of the many solutions that you can choose from. That is still possible, despite the fact that this toolbox is not yet customized for any specific place. That's precisely the reason why we used it in Xiangtan. It was not yet customized, but for training purposes, well, you can show what the effect of a certain solution is, etc.
Thanks. My good friend Peter Kinley from Arup, New Zealand asks, the toolbox seems to cover surface water and groundwater well. Can you please provide more information on how the interconnectedness to the wastewater and water supply systems are brought in?
That's a good question because they are not yet brought in. That is the brief answer to it. As you might imagine, how we are focusing on pluvial flooding and on drought. So on these issues, irrigation demand is not covered by this tool. We can do that in the urban water balance model, but the Resilient City Toolbox is not covering the water demand for irrigation, for example. What could be done, by the way, on the other hand, is introduce rainwater harvesting. If we one of the solutions that could be used in the toolbox is rainwater tanks. We can install rainwater tanks with a certain volume as a solution, as a measure in our plans. So that component is included, but for the rest of the short hydrological cycle of drinking water supply, wastewater treatment is not included so far. Thanks.
Christina Gregorio has another question. The resulting costing in the model is also in euro. Could the currency be changed to reflect local currency?
Of course, of course. I can show you the Chinese version, which is in yuan. This was a demo. As I said, it's not customized, so it was still in euros.
And I guess the unit rates of the concepts you're implementing, can they be changed as well? You mentioned before that they are in sort of the Dutch unit rates.
What do you mean with
any of the elements? Any of the elements, you must have unit rates for each element.
Yeah, that's to say that that can all be adapted to whatever the client prefers, because we can express the units and convert the units to whatever the client wants in the customization process, of course.
Thanks. Mikio Ishiwatari says, how can a river basin perspective be integrated into this urban tool?
Thank you for the question. Because the river basin perspective comes to flood protection from fluvial flooding, from the river flooding. Yeah, that is, well, for those who have watched very closely, the toolbox includes levees. But the levee only makes a spatial reservation for a levee and does not tell you how high the levee should be to protect you from river flooding. Because that is another issue that should come from hydraulic calculations. The river issue comes in when it comes down to the discharge capacity of a specific area. Currently, I'm working in a project in Nanjing in China, where all these huge pumping stations dump water to the river, with flooding downstream as a result. So one of the questions there is, how can we reduce that pumping capacity to minimize flood risk further downstream?
Thanks. Ragava Neti asks, can the solution optimize costing and outcomes based on feasible solution? So can you optimize costing and outcome?
Well, not in an automated way. What happens in practice is that people design alternative solutions and compare costs, of course, no wonder. But the nice thing about the discussions we have in practice during these workshops is that they tend to focus on the benefits rather than on the costs. Every now and then it feels like the participants are shopping in a candy shop. And we as facilitators have to say, hey, be aware that your costs are quite high. And then they tend to say, yeah, but these benefits are very, very attractive. So that also shifts the balance between costs and benefits discussions, the way we would like to have that, to have a fair and balanced discussion, not only focusing on the costs, but also on the benefits that could be taken from these measures, including the co-benefits.
Great. Well, the hour's up, I'm afraid. Elga, my colleague, has posted a link in the chat box for anyone who wishes to download the presentation. It will be available for 1 week. So go to that chat box now and click on it. And since the hour's up, I'm afraid we must call this interesting webinar to a close. I'd like to thank Frans van der Veen for his interesting presentation, and to Deltares for their cooperation with ADB. And we look forward to 4 more webinars over the coming months. Any last word, Frans?
Well, thank you for facilitating the discussion, first of all, Mr. Wilson. Any further questions? Well, my email address is in the presentation, and of course we will take a closer look at the chat and see what can be answered shortly. So if you have any further questions, please don't hesitate to contact us about the toolbox, because there's a lot more to say about this, as you have noticed.
Yeah.
But,
Okay, take care,
thanks
everyone.
again for
Stay safe.
hosting the webinar. Thank you.
Thank you.